I've got this triangle ABC with the following information. Could you help me draw in the triangle? Let's just do it on the right-hand side. Okay, where can I label my triangle as ABC this way? Our AC length is 1. My BC length is 3. Angle given is CAB. So this is your angle theta. What are we asked to find? I'm asked to find AB to show there is this formula. So AB is this side here. This is the question mark. So which rule to apply? In total, I have got 3 sides and 1 angle. So we should go for cosine rule. 3 sides, 1 angle. Okay, so let's start the problem with that. We go for cosine rule, and I will quote right from the start by cosine rule. The side opposite the angle is 3, so we start with 3 square. One of the sides unknown is called AB. We will write AB square, 1 square. Cosine angle. Let me move all my terms to one side. I want to move them to the right-hand side. And can I do a bit of rearrangement? This is AB squared. I've got another term with AB. So it's like quadratic equation, degree 1. So I write that next first. And I rearrange to write AB on the right. So last term is minus 8. I want to find AB. This is a quadratic equation. So to get the value of AB, we go for quadratic formula. Negative B. Negative B will become positive value. Plus minus square root. B square minus 4AC. Okay, let me simplify the coefficients first. There is a 2 at the top and bottom, and even in the square root, we can take out a common factor. There's a common factor of square root 4 inside that square root. So I take out square root 4 so that we get cos square plus 8. These common factors cancel out. Root 4 is also a 2. So these numbers will directly cancel out. On the next line, we will just get cos theta plus minus square root cos square theta plus 8. You have to decide whether you want to take the positive or the negative. So how do we reject one of the numbers? Note that AB is a length. I want to choose the positive value, but how to choose the positive value? Let me just compare the two numbers. Let's say I compare the cosine theta value with the square root value. Without the plus 8, these two numbers are equal to each other. So if I further put in a plus 8 inside, it must mean that the right-hand side is a larger value. Without the plus 8, it's equal. So with the plus 8, the right-hand side is larger. So with this, I can actually say that if we move all to the left side, the minus sign actually produces a negative number. If I move this to the left side, the minus sign here will produce the negative number, which we don't want. Okay, so I will quote that since AB is larger than 0, we will then choose the positive value. And we finish up the equation. The show question says that this should be a sine. The square root should be a sine, not a cosine. So you will make a change inside that square root. Cos square will be 1 minus sine square. Okay, then we move on to part 2. But up to this point, there isn't any binomial or Maclaurin series that comes in part 2. Again, sufficiently small, not important. What is important is we are expanding to theta squared. Okay, so let's apply the formula. I quote for you first so that you know what I'm trying to apply. Up to theta squared, sine theta is theta. Cosine theta, we go for 1 minus theta squared over 2. This is all from the formula list to apply the small angle approximation. Okay, so in part 2, we are going to start that way. I want to find AB. We will convert our cosine and sine. Cosine is 1 minus theta squared over 2. Sine theta is theta, so you will get theta squared. We take out the square root 9. Remember, for any expansion, we must force the constant to be a 1. So we get 1 minus theta squared over 9 over half. That power half will now mean a binomial expansion. So we have 1 plus n times x. I don't need the next term because the degree will be too big for us. Okay, so lastly, they just mentioned that you are supposed to determine those A, B, and C values. Let's just take from our equation and we compare. So therefore A is 4. You get B 0 and C will be negative 2 thirds.